Hello, today I'm going to be presenting my Unit 3 PowerPoint over resonance and the source filter theory. I will be going into detail about how source filter theory can be used in the production of the vowel E and if it can be used for the consonant M. What is resonance? Throughout this presentation, the term resonance will come up frequently, so to define it, resonance is the tendency of a system to vibrate with the greatest amplitude in response to a frequency that is close or the exact to its own frequency. This is what we call its natural frequency. We can simply define the vocal tract as a tube filled with air that allows the air to move in order for speech production to take place. The vocal tract is an acoustic resonator, meaning it has a closed and open end, a quarter wave resonator. It includes a series of air-filled containers. The pharynx, oral cavity, and nasal cavity has an irregular shape and is a variable resonator, which means the frequency response depends on the shape. The vocal tract acts as a filter and is made up of 4 cavities and 4 valves. Here, the 4 cavities of the vocal tract are listed. The nasal cavity is the uppermost part of the vocal tract. It produces nasal sounds that are produced when air is released. The oral cavity helps us understand sounds by moving articulators that change the vibration sounds produced in the larynx. The pharyngeal cavity is what connects your oral cavity to the larynx. And lastly, the laryngeal cavity is where the glottis is located. The vocal tract also contains 4 different valves: the labial valve, lingual valve, laryngeal valve, and velopharyngeal valve. All of these valves help produce different sounds by changing the shape of the vocal tract. These valves house different articulators such as the velum, tongue, and lips. They help completely close or just constrict the vocal tract to produce these different sounds. A few points I would like to touch base on prior to continuing onto source filter theory are the following. We know that sound starts in the larynx before being modified. Sound is generated by vibrations in the vocal folds and is then modified by the different resonances in the vocal tract. The vocal tract also acts as a filter. And lastly, before resonance characteristics can be changed, the shape of the vocal tract must change. When the shape of the vocal tract changes, the oral and pharyngeal spaces change as well. What is source filter theory? Source filter theory helps describe how vowels are produced and how they sound different due to the vocal tract filtering glottal sound waves. This theory consists of 3 spectrums. The source function helps one determine that the glottis is a starting source for all sound. The transfer function is the vocal tract transferring the sound source to the output function. And the output function represents the sound leaving our lips. The source filter theory plays a role in the production of vowels. A vowel is a speech sound that is produced without any blockage or constriction of the vocal tract. In elementary school, they taught us our vowels are typically A, E, I, O, U, and sometimes Y. In this PowerPoint, I am going to detail the process of speech production for the vowel E, also seen as a lowercase I. It is a high front, unrounded, and tense vowel. When said correctly, it is said similar to the letter E sound. A few words to help correctly depict the vowel E are Easter, teacher, and keep. When looking at the diagram on the right, we can see that E is the highest and most fronted of all vowels. Going back to source filter theory, the first spectrum is the source function. The glottis is the source of the vowel sound for E, and the glottis is also where the fundamental frequency takes place. The rate of the vocal fold vibrations give rise to the fundamental frequency. Harmonics are multiples on the fundamental frequency, and harmonic spacing depends on the fundamental frequency. Next, the transfer function is where the vowel sound is transferred to the output function. This happens in the vocal tract. This is the function that determines the articulation of the speech sound. Articulation is what determines the frequency of different vocal formants. The transfer function occurs in the vocal tract, and because the vocal tract has a closed end and an open end, we refer to it as a quarter wave resonator. Different valves manipulate the sound source, so because E is a high front vowel, the pharyngeal cavity and the velopharyngeal valves increase in volume, and the volume of the oral cavity decreases. Volumes are also changed by the tongue moving. The output function of the vowel E takes place whenever the sound leaves the lips. The lips have what we call a radiation characteristic when the sound hits the atmosphere. The lips are acting as a filter. The same fundamental frequency and harmonics that are present at the glottal source are also present here. When the lips expel the E sound, the lips are unrounded. Now, I will explain the process of producing the sound. Unlike the vowel E, is a consonant. Therefore, it is not produced and does not sound like a vowel. In the production of the sound, the mouth is completely closed and the lips are rounded and closed. Is produced as a nasal sound, what we call nasalized. This means that the air moving from the vocal tract travels out through the nose because the mouth is closed. Therefore, the vocal tract is blocking the air. The diagram to the right demonstrates this. The source function of the consonant is also the glottis, and the transfer function happens through the vocal tract. Unlike the vowel that I used, the output function of is the nasal cavity. In order for the air to pass through the nose, like it was mentioned in the last slide, the mouth is closed, but it is also a result of the velum and tongue moving. The velum and tongue are both articulators. When the velum and tongue move, air is blocked from leaving via the mouth. We call the sound a bilabial nasal sound.